Hello, Leon. It's your Zayde, Mason, and we are going to read a book today about quantum computing for babies. This is for you. So, let's begin. This is a ball. This is a red ball. It can be red or blue, actually, in this case, unlike some of the other ones. It is 1 bit of information. 8 bits of information, that's 1, that's 8, they make a byte. That's what we call a byte of data. And many bytes make data overall. See, some of them are red and some of them are blue, and they tend to represent zeros or ones in data. So, data lives on a computer. So we write code with bits and bytes that are in zeros and ones that make data that lives on a computer. Computers are useful. They solve problems. Like, you put in a problem and it gives you a solution. So we think of difficult questions and we use computers to find solutions. Problems are solved by changing data. That is to say that the data that the computer uses processes it, and the ones and zeros move around to help solve the problem. Some problems are very easy. 3 times 2 is 6. You'll learn your multiplication tables soon, and that is a very easy one to learn and solve. But some problems are hard. Here's one. How do you get 6? Well, the computer has figured out that it is 3 times 2, but you can ask it much more difficult questions. Some problems are too hard for a computer using regular bits. So, as we saw, 6 equals 3 times 2 is a fairly hard one to solve just by itself, but what happens when you have 8,777,379,000? Ooh, that's actually 8,777,379,000, and so forth and so on. Anyway, yeah, some are very difficult for regular computers to solve. Even though they're good at solving problems, some are very difficult. But wait, look, is this, what is this down here? Is that a blue ball or a red ball? No, it's a rainbow ball. We already talked about rainbows. This is actually a quantum bit, which we call a qubit. See how it's got multiple colors? Instead of just red or blue, it's got a whole bunch of colors. It can be red or blue or anything at all. And that's because when we're not looking at it, it has multiple states. It can be red or blue or anything because we haven't looked at it yet. And many qubits make quantum data. Now, we've talked about quantum mechanics before, but this is quantum data in computers. Quantum data lives in a quantum computer. And see how the qubits are all going into a box? Well, we don't see inside the box, but we do use the computer as a box that solves problems. Regular data with zeros and ones can be copied, because you can copy the zeros and ones, but quantum data cannot be copied because you don't know what the data state is. It has to be identified after it's done its computation, or else we haven't collapsed the waveform, but we won't talk about that right now. We can watch a computer doing its work as it's computing, and it can provide us answers or even partial answers along the way if we do it right. But we cannot watch a quantum computer at work because all we can do is give it the question and get the answers, because that is how quantum mechanics works. When you collapse the waveforms, and qubits are in a state of 0, like red, or 1, like blue, or in a state of 0 and 1, which is multicolored, and we don't know what state it's in. We can only see the answer that it gives. So you put in qubits, you give it a question, and it gives you an answer in zeros or ones that we can see. So why do we want a quantum computer? It's a very good question. Why indeed would we want it? Because quantum computers can solve really hard problems. So we can give it a really big question that's very difficult to solve. And it can give us an answer of this number is a multiple of, it's not a prime because it's a multiple of two very big primes. Now, you know quantum computing, or to an extent you do. And sometime in the future, we will talk about it when you have more understanding of computers and quantum mechanics, and we will have good conversations about it. But anyway, there you go. That is quantum computing for babies. I love you very much, Leon, and I look forward to the next time we get a chance to read a book together, okay? Bye for now, and enjoy your quantum computing.